Today from Group 9, we present our mini project for inverse engineering of coffee maker. My name is Nordiana Mitizaba, metric number B0920102773, and I would like to present to you the background of coffee maker and the part list of our product. Every coffee drinker knows their espresso for their filter coffee, but how many people understand the history of coffee maker? Today's espresso machine range from the very simple system that you can place on your own kitchen counter to sophisticated technologies that eliminate any chance of a bad brew. The first patent for a coffee percolator was filed by American James Jason in 1865. Due to the rapid acceleration of electronic technologies over the past 2 decades, espresso machines are now more sophisticated than ever. Now, advanced machines can grind, compress, and brew coffee perfectly and completely, producing incredibly flavorful espresso at the touch of the button. Now, there are 19 parts in our product. First, base, wire plug, wire tube, kettle lid, jug, kettle handle, ring heater, dripper cover, kettle connector, rubber holder, spring, filter, water container, water tube flow, lid, water lid, bottom cover, and 2 water tube transfer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nasrin Kisnaminta Nazaruddin, and today I'll be presenting 2 parts of the project, which is simulation and the measurement. For the measurements, we use 2 types of tool, which are the vernier caliper and the ruler. For the vernier caliper, we use them to measure the depth and the width of the project. For example, we use to measure the jug, the kettle cover, kettle lid, the base cover, and many more. Next, we also use the ruler. The ruler we use to measure linear length of the project. Linear length of the project that have in the project are the lid, the base, the water container, and so much more that we use. And next, we will proceed to the simulation. For the simulation, there's 2 types of simulation we use, which are stress and displacement. And we also use 2 types of parts, which are the kettle connector and the kettle handle. For the kettle handle, we use a load that is 1 lbf, and as you can see from the deformation for the stress, there's not much deformation. This is due to the von Mises stress. The maximum and minimum isn't too much of a difference, but however, for the displacement, as you can see, there's a bit of deformation at the curve of the handle, and as you can see, the von Mises of the max and the minimum are like a bit. There's a little bit of difference, and as you can see, the color also indicates how much the stress is taking. The displacement is taking. Next we use is the kettle connector. For the kettle connector, same with the kettle handle, we use a load of 1 lbf, and we use 2 types, which is stress and displacement. As you can see, both doesn't have much difference in terms of deformation, and this is due to the von Mises stress indicator that they both have like similar between the maximum and the minimum. And due to all of this simulation, we can see and use the simulation results to improve our coffee machine for the better use. Next, I'll be giving it to my friend. Thank you.
Hi, my name is Noatira Najwa and I will be continuing the presentation about drawing, exploded view plus bomb, and realistic photo rendering. First, this is 2 examples of part drawing where we have the front, top, and side view of the part, plus the dimension of the part. Next is the assembly drawing where we also have the top, front, and side view of the drawing, plus the trimetric view. Okay, now this is the exploded view plus boom, where we list all the part, the number of part, and the material of the part. Finally, this is the realistic photo rendering of our coffee machine that we make to provide an accurate presentation of how the product will seem in real life.